All right, today we're going on a hunt for the code of the universe. And you know where we're going to start? Inside a simple soap bubble. What secrets could a tiny bubble possibly hold about, well, everything? Let's find out. I know, it sounds like the beginning of a weird joke, right? Bubbles, the atoms that make up life, and our own consciousness. What on earth could possibly connect these three things? Well, the link is way more profound than you might think.
The secret here is analogy. It's about seeing a pattern in one place and realizing it reveals a deep, deep truth about something else entirely. We're about to follow a chain of these patterns, starting in a kitchen sink and ending, well, with the very structure of the cosmos.
And it all kicks off with the humble soap bubble. I mean, you probably think of it as just a fleeting, fragile thing, right? But over a century ago, a physicist named Joseph Plato discovered that bubbles follow an incredibly strict and, frankly, beautiful set of rules. These are Plato's laws, and what they show us is that bubble foam isn't random at all. Nope, it's a perfect expression of efficiency. The laws dictate exactly how soap films have to meet. So three surfaces will always intersect to form one single line, and four of those lines can only meet at a single point. But the really mind-blowing rule is all about the angles. Every single time three soap films meet, they do it at a precise angle of 120 degrees, not 119, not 121. It's always 120. Why? Because it's the most stable, most energy-efficient arrangement possible. It's like a law of physics written in the language of pure geometry. And it gets even crazier. When four of those intersection lines come together at a single point, the angle is even more specific, 109 degrees and 28 minutes. I mean, that is an oddly precise number for something as simple as soap and water, isn't it? It's almost like a secret code. But here is where it gets truly mind-bending. This isn't just about bubbles. This hidden geometric code, it shows up somewhere else. Somewhere on a scale so small, it literally forms the basis of life itself. So let's take our first leap of imagination. Okay, just look at this. The parallel here is stunning. On the left, you've got that node in a soap foam. On the right, a carbon atom, the backbone of all life as we know it. When a carbon atom forms four chemical bonds, the angle between them is about 109.5 degrees. It is the same tetrahedral angle dictated by efficiency in the bubble foam. The exact same pattern of stability, just repeating on a microscopic scale. Wow. This parallel just begs a bigger question, doesn't it? If a universal principle, like saving energy, creates the exact same pattern in things as different as bubbles and atoms, could a similar universal pattern exist for something less physical? Could there be a fundamental geometry to how we think, and maybe even a truth itself? To explore that, we need to hop in a time machine and jump back to the 15th century to meet a brilliant thinker named Nicholas of Cusa. He used a really powerful geometric analogy to describe the very limits of what we can know. So, Cusa explained it like this. Imagine you're trying to turn a polygon into a perfect circle. A triangle inside a circle, it's a pretty bad fit. A hexagon? That's better. A polygon with 100 sides gets even closer. You can keep adding sides infinitely, getting closer and closer and closer to the circle's true form, but you will never perfectly become it. For Cusa, our intellect is the polygon, and absolute truth, that's the circle. And this whole idea is the heart of his philosophy. He called it docta ignorantia, which means learned ignorance. Now, this isn't about being uneducated. It's actually the opposite. It's the profound wisdom that comes from understanding that our knowledge can always get closer to the truth, but it can never grasp it completely. Just like that polygon can never truly become the circle. Real knowledge is knowing what you don't know. Cusa used another killer analogy to explain this. Think about it. A blind person can hear 1,000 facts about the sun, its temperature, its size, whatever, and they might think they know something. But a person with sight who experiences the sun's brightness directly knows that its brilliance is beyond their ability to fully describe or even comprehend. So if you ask them to define it, their most honest answer is, I don't know. That is learned ignorance. So if our minds can't ever perfectly grasp the truth, then what are they even for? Well, Cusa and other thinkers who followed him argued that the mind isn't just some empty bucket for facts. It has a very specific structure and a very specific purpose. See, Canassa argued against that whole blank slate idea. He said our minds come pre-equipped. We're born with an innate power of judgment. It's like having a built-in compass for reason that lets us tell a good argument from a bad one. and it's what allows us to learn in the first place. The mind isn't empty. It's an image, a reflection of the very structure of reality itself. The philosopher Leibniz later really sharpened this idea. He said the difference between a rock and a mind is like the difference between a mirror and a person who can see. A mirror, it just passively reflects whatever is in front of it. But a mind understands. It actively expresses the underlying principles of what it's seeing. And this brings us to what I think is Cusa's most beautiful metaphor. He described the mind as a living mirror. Think about that. It's not a static piece of glass. It's an active, dynamic tool added to our bodies to reflect, understand, and perfect our connection to the world around us. Okay, you with me? From the bubble to the atom to the mind, now we're zooming out to the final, grandest scale, the entire universe. What if the whole cosmos runs on the same principle of elegant efficiency we saw in that very first soap bubble? This was Leibniz's great idea. He proposed that out of all the possible universes that could have existed, the one we live in is the most perfect. Now, what does he mean by perfect? He means it operates on the simplest possible set of rules, the simplest hypothesis, while at the same time producing the most complex and interesting results, the richest phenomena. And look, this isn't just some abstract philosophical thought experiment. It's a potential explanation for why we see these patterns everywhere we look. That 120-degree angle in the foam, the elegant way animals are built, the laws of physics themselves, maybe they're all just expressions of this one single beautiful principle of perfection. And this hunt for a simple code, it didn't stop with Leibniz. The great 20th century logician Gödel, who was friends with Einstein, he saw his own work as being part of this very same tradition. The search for a simple, logical foundation, a kind of universal code from which all the complexity of the universe just unfolds. And so we've come full circle. We went from a bubble to an atom to the mind, and finally to the universe itself. And it's all connected by this single principle of elegance, revealed through the power of analogy. So it leaves us with one final thought. If the universe is written in a simple code, what other everyday things are hiding the secrets of the cosmos? What other analogies are out there just waiting for us to discover them?